Okay, this is a video walkthrough on how to calculate U-shaped stairwells for second year, H-line, H5. This is typical of a lot of the math sheets that you'll get. So you have a list of specifications. And like any stairwell opening calculation or stairwell calculation, we need to figure out our true rise and our unit run. Okay, so that's the first move, is to take that total rise, 2627, divide by the desired rise. Let's just have a look here. Divided by the desired rise, 195, gives you 13.4 risers. Now the instinct here might be to round down. I think in this situation, if you round down and you try to get a rise, 2627 divided by 13, you get a true rise of 202 millimeters, which does not meet code specification. It has to be under 200 for code. So we will go with 14 risers in this situation and 13 treads, always one less. So the true rise in this calculation becomes 2627 divided by number of risers, and we get 188. Based on our proportioning rule given above, 455, we can now calculate our unit run. 455 minus 188 gives us 267. So there's the two pieces of information that we need to keep moving forward. What else does the sheet say? It tells us we've got 5 risers in the top flight and we've got 4 risers in the middle flight. So now is a good time to draw a picture. And here's the picture I drew. U-shaped stairwell, 2 landings, landing number 1, landing number 2, so the A will be the top. We have 1, 2, 3, 4, 5 risers, these lines indicating the rise, and the space between indicating the horizontal or tread. And then in the middle stair, we have 4 rises, 1, 2, 3, 4. And then the remainder would be down here at the bottom, and it wasn't drawn completely here, so whatever remains. So we have 5, 4, that's 9, and then we have all 5 remaining. So 1, 2, 3, 4. We do have it drawn correctly. So this is what it would look like from above. Okay, the next steps, and they don't ask for it on the sheet, but you will need it to determine where the stairwell is going to land. Similar to the other video, walkthrough video on a straight stair with a landing, we need to determine where the stairwell is going to end. So we do that by figuring out the headroom gained at each landing. So the headroom gained at landing 1 will be the number of total rises above the landing, 1, 2, 3, 4, 5, multiplied by the actual rise per step, which is 188, and that gives us 940 millimeters. When we have a headroom gained at the lower landing of the total number of rises above the lower landing, that would be the rises in this one and this one, working our way to the top of the stairs. In this situation, it's 9. So we take 9, multiply by 188, the true rise, we get 1620 or 1692. Now, although it's not on the sheet, we also need to figure out, well, we should recognize, let's see, that the vertical distance we're going to need to frame in our stairwell opening will be a function of our headroom clearance, which is 2000, and our floor frame, which is 227 millimeters. So put those two together, you get 2227. Okay, so that's the amount of vertical space you need above the stairs, to frame in that stairwell and meet code based on the clearance. Okay, so 2227, and we need to recognize in this situation that the headroom gained at the lower landing, 1692, is less than what we need for headroom clearance, meaning we need more vertical space to frame the stairwell in, and that the stairwell rough opening is going to land in this stairwell C, somewhere in here. Okay, once we recognize that, we can calculate stairwells A, B, and C. We have stairwell A, and it's just a game of addition. We take the number of treads now. This is a horizontal distance. 1, 2, 3, 4 treads in stairwell A, plus the landing length in this situation is the stair width, 900, plus we're going to give a 75 millimeter allowance. And here's the calculation here. It comes out to 2043. We can follow the same step in stairwell B because we know that the stairwell rough opening is going to be in stairwell C. So in stairwell B, we have 2 landings, so 900 each, and 3 treads. And we'll also add a 75 millimeter allowance for finishes. And that's what we have here. 3 treads, 2 landings, 1800, and the 75 mil. So the length of stairwell B will be 2676. Stairwell C now is where we actually calculate where to frame the floor above. We're going to punch all these things into our formula. So we have our run over our rise times, we have the headroom, 2000, plus the floor frame. But what we have to do now is subtract the headroom gained at this level. So the vertical level at this landing, we calculated to be 1692. So we're going to subtract that headroom gained from this formula. And we're also going to add 75 millimeters as we usually do for finishes, sorry. So that formula gave us 760. Now this is where it can get a little bit confusing. So based on this formula, what we've just calculated is the horizontal distance working our way down from that landing. So if we try to put that into number of treads, what that is saying is 760 divided by our run, 267, is 2.8 treads, which tells us 1, 2, 3, so we're just shy of this tread, or this riser line here. So 2.8 treads will sit in a stairwell. So this formula will get you the distance from the landing down the stairwell. So if you're trying to calculate the stairwell opening here, you need to also add the landing length to the number that you get from the formula. So the 760 plus the landing, and we're also going to add the 75. And so we now know that this stairwell rough opening for C is going to be 1735. So we'll frame it off right here.